Okay, let's get started. Thanks everybody for joining us to the start of the 2023 webinar series. I'm pretty excited to announce that Zen Engineering, I'm sure most of you have heard of Zen Engineering. If not, you need to. Mark Ditko owns Zen Engineering. He puts out these fantastic books and teaches classes on open roads and drainage, which Carl will be doing for us today. So I'll show a couple slides in a second here, but Zen Engineering offered to load us up this year. You'll be given 6 webinars. We do ours every 2 months. We also are going to have some webinars with MDOT regarding the RID process. So this is a specialized webinar for MDOT people working on MDOT projects. So we'll come out with more information on that later, but that'll be just specialized for MDOT work. If you can see my screen, we're happy to and excited to announce that we got our Bentley User Group Conference, July 13th and 14th of this year at the Kellogg Center on MSU campus. The price is going to be $225. That covers 2 days of lectures and workshops and includes breakfast and lunch for both days. We're going to be sending out a survey next week, and we would appreciate it if all of you took the time to fill that survey out just so we can make this conference a great conference. And then after that, sometime in February, we're going to be sending out the official invitations. And the class schedule. So please get the word, start sharing the word about the upcoming conference. I know there's budgets have already been probably made for this year, but just get the word out. So like I said, Zen Engineering, Mark's based in Los Angeles, California. He puts out these fantastic books. I got to be honest, I learned how to do open roads design through his old SS4 book, I think. I just stepped through it step by step, and they're real easy. They're great information to have in your office. So I just want to go through, this isn't a sales pitch, but these books are really awesome. And if you have any questions on the books, you can just go to his website, which is zenengineering.com. He's got, the essential series, the primer, which just covers really all the basic stuff about open roads. And here's the open roads essentials that can walk you through foundation, terrain, geometry, sections, modeling, and sheeting. He also has the specialty series, the primer, and drainage, survey, geometry, and he's coming up with future volumes. These are all great books. And this is his training series for people who want to train, do some classes. This goes step by step for whatever Mark or Zen Engineering uses for their training. So I encourage you to go to zenengineering.com and look it up. These books are really, truly excellent. So let's get through. Carl Dauber is going to be, he's a drainage expert. He'll be doing the webinar today. He has his own firm, Advanced Consulting, but he works with Zen Engineering to do the drainage books. We also have the drainage book. It's excellent. We learned from that. Like I said, all these books are great. But he's graduated from University of Maine in 1985. He's a professional engineer in Jersey, Pennsylvania, North and South Carolina. His specialty is drainage system design, stormwater management, floodplains, hydraulics. He's been in the industry since '85, but now he has his own consulting firm. So with that, I'm going to hand it over to you, Carl. This is going to be a probably an hour long, so it might be a little bit longer than an hour. Oh, I just want to tell you one more thing. If you're on this call and you're calling in by yourself, I'll get a list of who's calling, and then there will be PDH hours that you'll be given. I'll send this information into Bentley and they'll give you the PDH, and you can check your PDH on the Bentley website. If you're in a conference room with multiple people, you can send me their names and email addresses, and I'll put my name in the Q&A and my email address, so you can send me them and I'll get them PDH credits. So with that, go ahead, Carl.
All right, if you could stop sharing, I'll go ahead and share my screen.
I think you can just go ahead and override me, but
It's when I try, it says you cannot screen share while other participant is sharing. When I try to share.
okay, there you go.
All right. And... all right. You see my screen, Chuck?
Yes.
All right, excellent. All right, I'm going to dive in. Ditch design, ditch modeling is a big topic. There are a lot of different kinds of ditches and a lot of ditch issues when it comes to modeling. For example, ditch intersection modeling is not something I'm going to be covering at all today. So we're going to look at one specific, although very common type of ditch. I want to refer to these as lateral ditches, ditches that run alongside a roadway fill slope. And so we naturally, these lateral ditches have a relationship with the roadway. And what often happens is, right, the roadway design changes, and then you have to redo your ditch design, and that's frustrating and very time consuming and expensive. And one of the things that we're going to use in open roads that we want to leverage is the ability to develop dependencies or ruled relationships between different civil features. So for example, we want to create a ditch that has a ruled relationship to the fill slope line, the total fill slope for this road, such that when this road design changes, the ditch will move along with it, which will save us a lot of time and energy. You still have to go back, of course, and check that ditch and refine its profile, perhaps, since it will be in a new location, but that's a lot better than starting from scratch. So for example, here's in the upper right corner, I have the profile shown for this roadway. So I'll activate that window and select that profile. Grab the starting point of that profile. And you can see in the lower left corner in the 3D model view, you can actually see that profile 3D linear as I'm moving it around. So I'm going to change that profile and watch the plan and 3D model view and cross-section views update. All right, so that's what we're shooting for. We've made a change to the road. The ditch is adjusted automatically. Our contour plan has updated. Our cross sections have updated. So that's what we're looking for. That's what we want to create. And well, we remember with open roads, we now have an undo button that functions. All right. I'll show you a couple of other things that you have when you set up your ditches using a corridor model. It's relatively simple to go back now and make some design changes. So for example, let's say I want to make a change to the bottom width of this ditch. You can use something called a parametric constraint. I'll activate my plan view window. I want to select my graphic here. This is called a corridor handle that enables me to do some interactive, very easy, intuitive design changes. You can do these. You can go to your ribbon menu and find all these tools. If you like using ribbon menus, I prefer to use the flyout menu right here. Go to my corridor creation tools, drop down to create a parametric constraint. Parametric constraints are really straightforward. They allow you to make changes to a variety of point constraints that are in your template. And you simply provide the station range over which you want to make the change, identify the particular constraint that you want to change and what the new values are. So here are some of the things I can change. Bench width, that's That's the width of this bench that exists between the toe fill slope and the force slope for the ditch. You can change that dimension, the bottom width, and the force slope and the back slope. So I'm going to go ahead and change the bottom width. I'm going to change this from a 4-foot bottom width to a 10-foot bottom width, something we can see pretty easily. Change these values. Now that I've got those inputs in there, and I'm going to apply this to the first 200 feet. 250 feet of the ditch, which is the lower part of the ditch. So from station 0 to 250, and that's what I'm going to change. And here's the new values. And I'm going to just data point, left click with my mouse to accept all of those inputs. All right, and there's the change. And it's very dynamic. Everything is still tied together. If I want to put in a transition, that's a pretty abrupt change there in the bottom width. Maybe I want to have a transition and go back, go through the same process, corridor creation tools. Change my station range. I'll give this a 20-foot transition. And at the end of that, I'll transition back to the original value and then accept those inputs. And there's the transition. So you can do this with, any point constraint that's part of your template definition. What if I want to add riprap to the bottom, that widened portion of the ditch? You go back to my corridor handle, my corridor creation tools. I'm going to add a template. I neglected the beginning of this. One of the things you need to do when you're working with corridors is make sure you have the right template library loaded up. Got to do that. Let me go ahead and do that now. That is not the right template library, so I need to go get the right template library. Here we go. Now that I have my right template library, I can go ahead and drop in a new template into my ditch corridor. Okay, this is pretty simple. You just have to specify the range over which you want to add that template. So from 0 to 250 and the drop interval and what template you want to use. By default, the corridor that was set up, it was set up with a earth lined. I'm going to add riprap section to that last 250 feet. And accept that. Accept all my other inputs. Oh, need to change that back to 0. Come down here and update my cross-section view. There's the riprap lining. Template for that includes riprap and as well as bedding. If I wanted to add using parametric constraints, I could change the thickness of the riprap layer, the thickness of the bedding, the height of the lining, for example. Okay, so all of that is something that you can then come back and revise later. You can see the riprap in the 3D view, and in the plan view, we have new graphics here showing the limit of the riprap line. And you could use that for patterning if you want to for your construction plans. So that's a quick overview of what I want to create and where we want to go. So next, I'm going to look at, well, what's needed to do this, and then we'll dive into the actual process of how it's done. So to do corridor modeling, there's some just basic things that you need. Of course, you need a terrain, right? You need an existing terrain so that the back slope of your ditch has something to intersect with. You need your roadway corridor model, of course, and we're going to be tying our ditch to the toe of slope feature from that corridor model. And we need a template library, as you've seen. So we're going to use our toe slope as the control. We're going to apply a template to it, and that template will intersect with the existing ground. So those are the basics that you need. All right, I'm going to go ahead and open up a different file. I'm going to show you two different methods of how to do the how to do lateral ditch modeling. Chuck, is this still looking good? You still see all this? I got a message that popped up. I want to make sure we're still good.
Yeah, I can see everything.
Okay, thanks. So this is a project example. This is a road widening project, and we have a proposed roadway corridor has been run for the widening. You can see the proposed contours and the fill slope. From that, we have some drainage. We have some utilities in here. And I'm going to be creating a lateral ditch that's going to run from this point here all the way down to the stream crossing down here. Now, the roadway stationing actually runs from left to right. So that'll be the stationing for the ditch as well. So it actually will start here and end up here. So I need to go and make sure that I've got my template library loaded up. It looks good. Want to make sure that you're in your open roads modeling workflow. That's where corridor modeling is done. I'm in the corridors tab, and I'm going to use the tool new corridor. Look at my tool settings dialog. I want to set my feature definition. I have some feature definitions available. I'm going to use the final design feature definition that will provide contours. So I'll use that one. Looking at my prompts here, my first prompt is to locate the corridor baseline. So this is the baseline for my ditch corridor. And what I'm going to use as my control is the toe fill slope for the roadway corridor. And if I hover over it, look at my attribute feedback, it tells me that that feature is called fill underbar left. So that's the name of the feature that comes from the template that was used for the roadway corridor. So that's what I'm going to tie my ditch to. That's going to become my control line for the ditch. And that's very important. I'm going to be coming back to that again in a little bit. So I'm going to go ahead and select that. The next prompt is to locate the profile or reset for active profile. Now that toe of slope feature was generated from the roadway corridor. So it has not only a horizontal aspect to it, but it also has its own profile. So I can go ahead and right click and accept that as the profile. Next prompt is corridor name. It automatically uses the name of the feature that I selected for the control. I'm going to override that and give this a little bit better name. The next step in the process is to identify the template that I want to use to create this ditch corridor. You can go into this ellipsis button right here and bring up the pick template dialog. Alternatively, if you like using the heads up display, you can press your Alt key and your down arrow key at the same time. It does the same thing. This is basically looking at that template library that I opened up at the beginning. So I'm going to start with, let me use an earth-lined channel. And notice the type of template that I have here. This is a template that's specifically designed to be used as a lateral ditch on the left side of the road. Here's that green point. That's going to where the template, that's its origin. That's where it's going to connect to the fill slope line for the roadway. You can use this would be a template that you would use if you had an independent ditch that wasn't being tied to anything. The origin point would be at the center of the ditch. And remember, you can always use a parametric constraint to convert a trapezoidal ditch into a V ditch by simply making the bottom width 0. I'm going to go ahead and select that one. And then data point to confirm that selection. Now I need to identify the start and end point of my ditch. Remember that, again, I'm using my control line is the toe slope feature for the roadway So I'm going to start down here. I could identify this graphically by just clicking on a point, but I know the actual stations that I want to use is around 333. I'm going to press enter to lock that value in. You see I've got a lock symbol in my heads up prompt and a data point to accept that value. Next prompt is to end the station. I'm going to end it up here at around station 1270. Press enter to lock that value and then data point to accept it. Last prompt is for the template drop interval. This is a critical parameter for corridor modeling in general. When you're working on miles of roadway, it's something you have to give a lot of thought to. How many template drops do you really need and want? It really affects your processing time and speed and file size. For ditches, these are relatively small corridor models, so I use a rather tight interval. So I'm going to go ahead and use 2 feet. And once I do that, that's the last input. And go ahead and exit the process. You can see I now have a ditch corridor in my file. You see I have it in my 3D model. And my ditch corridor is now tied to the toe slope of the roadway corridor model. I'm going to go to my references. I'm going to turn on display of my 3D model. And I'm going to turn off some levels as well. I'm going to turn off display. I want to turn on display for the 3D model so I can see those contour lines, but there's a lot of other stuff I don't want to see. So I'm going to turn off display of this of that level, and I'll turn off the template drops and clean that up a little bit. So now you can see the contours for the ditch. Notice I've got this sketchiness that's going on here with these contours. The reason that's happening is that I have crossing templates. This method that I'm showing you, using your toe slope feature for laying out a ditch, it works really well if that toe slope feature is smooth and doesn't have a lot of deflection in it. If it does have deflection, then you can end up with crossing templates, and that will happen. One way to get around this is, and I'm not going to demonstrate this, I'm just letting you know, if this happens to you, what you can do is lay out, using geometry, lay out a horizontal alignment, an independent horizontal alignment along your toe slope. So you're creating a new horizontal alignment. You can then drape that horizontal alignment on the existing ground to create a vertical for it. And so now you'll have a horizontal and vertical alignment, which you can then use for your ditch. The difference is now that you have control over that, and you can go ahead and add a horizontal curve here. You can move the PI points in and out to smooth that out a little bit, and that will then resolve your crossing templates issue. I'm going to create a dynamic cross-section view. It's important that we have that whenever we're working with corridors. We want to see how things look in cross-section view. You can do that from the ribbon menu, or you can do that right from the corridor model itself. Put that down here in window 3. I'm not seeing a whole lot there. Normally a cross-section view cuts through everything that's in your 3D model. I just need to go and make sure that I've got levels. All my levels are turned on that I need. There's a few that are not turned on. Go ahead and turn them on. And my terrain, I want to see my terrain. Now I see what I want to be able to see. Notice when I'm using this arrow, it always by default will come back and show you the ditch corridor model that the cross-section was set up to see. I would like to have that, be able to see all these other things. You can come over to view properties and say center on current offsets. And then as you move up and down through the corridor, it won't keep changing on you. And see what I've got in here. I've got my pavement layers from my roadway corridor model. I've got my existing ground. I even have some existing utilities showing. So whatever you've got attached in part of your 3D model, it will show up here in your cross-section view if you, of course, have the levels turned on. So I'm going to leave that there so you can see the changes as we go along. Next thing I want to do is create a profile for this. So I'm going to open up a profile model. Let me go back and turn off display. Oh, got to activate my plan view. All right. Turn off display of my 3D model. That'll clean that up a little bit. I want to create a profile model for my ditch center line. So this is the ditch center line that was created by the ditch corridor that I made. I'm going to go ahead and select that. Go to open profile model, and I'm going to put it over here in view number 2. So there is the profile of the center line of the ditch. And that's not a very good profile, is it? Why does it look like that? Well, what we did was we applied a ditch template. And that ditch template is tied to the roadway fill slope. And that roadway fill slope goes up and down all over the place as it intersects with existing ground. So it's not a smooth downward slope at all. It goes all over the place. We need to apply a profile to this ditch, an independent profile, so that this ditch has a profile that drains in a downward direction the whole way. We need to eliminate these low points and high points that we have. And we're going to do that using something called a point control. What a point control does in corridor models, it overrides a point in your template. So in this example, this template works from right to left. It starts here and it works out, it goes out a certain specified bench width, and it goes down at a certain slope, a certain distance, goes over to the left for the bottom width, and then goes up at a specified slope until it intersects with existing ground. We want to override the elevation of this point. Instead of this point being a fixed distance below the top of the force slope, we want this to float. We want this to follow a profile that we specify, and we want to maintain this force slope. So what will happen is this ditch will float in and out as the location, the horizontal location will go in and out as necessary to maintain that force slope when it intersects the elevation from a profile that we are now going to create. All right, so we're going to create a profile, and we're going to use that, and we're going to apply that as a point control to modify our ditch corridor. So I'm going to show you here method 1. I'm going to come back later and show you a different method for establishing a point control. This first method is going to use what's called elevation and grade. I'm going to be working in my profile view. I'm going to turn on Civil AccuDraw. Civil AccuDraw enables you to enter in precision inputs. So I'm going to be creating a profile in here with specified station and elevation. I'm going to turn off my persist snaps. This allows me to use I can use snaps in my profile without creating a rule. I don't like to create rules when creating profiles. It makes it more difficult later to come back and make changes in the profile view. So I'm going to go ahead and turn that off. Then I'm going to go to geometry tab. So I can use my profile tools over here under vertical. Go to profile complex by PI. I'm just going to lay out a series of PIs to create my profile. And because I've got Civil AccuDraw turned on, you see on my heads up prompt, I've got station, elevation, key in fields that I can use. When you're using this tool, make sure that both the vertical curve parameter and the curve length are set to 0. Make sure you zero these out. That's important. You can get some glitchy results and difficulty using this tool if these are not set to 0. And then go ahead and check that curve length box. And we want We don't, just not important what the vertical curve type is because we're not going to be adding vertical curves to our ditch profile. Do need to select the feature definition. I'm going to opt to use my feature definition toolbar to set that, so I don't have to keep doing it over and over again. Select the feature definition called drainage baseline and make sure to use the use active feature definition toggle. Turn that on, and now this tool will automatically use that feature definition that's been specified. I won't have to keep picking it over and over. And we're going to go ahead and I'll keep that default name there, drainage alignment 1. And now I'm ready to go ahead and lay out some PIs to establish my profile. In the beginning, I'm going to go ahead and just let that snap to the beginning of the profile, tab to my station, field, press enter to lock that station value in. You see that's locked. And now I just need to go ahead and specify an elevation. I've got a series, I've written these down, a series of PI points that I'm going to go ahead and put in. First elevation is 524, press enter to lock that. You see it's locked now, data point to accept. Next station, I'm going to go ahead and key that in, 82, press enter to lock the value. You see that's locked. Enter in the elevation, 524.88. Press enter to lock that value. Data point to accept that PI. And I'm just going to go ahead and walk that through the rest of the PI points. Next one, 131. Press enter. Elevation, 526.58. Press enter. Data point to accept. 184. 530.72. Accept. 627. 533.47. And last one, I will snap to the end, lock that station value, and then specify the elevation, which is 542. Data point to accept, reset to end the process, and escape. So there is the profile that I've created. This is a temporary profile. I'm going to use this profile for my point controls. Done with Civil AccuDraw, I can turn that off. I can go ahead and put my persist snaps and rule, my persist snaps toggle back on. Now, I want to explain something, and this is what causes a lot of problems for ditch modeling that sometimes people have a hard time understanding. So I spend a little bit of time on this. There are 3 different baselines that you need to understand that are going on here. One is the roadway baseline, right? We have the horizontal alignment for the roadway. We also have a toe slope feature. And that feature has its own baseline. It does not run during the entire length of the roadway. It starts and stops in different locations. And so it has its own station base. And then finally, we have the ditch center line itself. And that also has its own baseline. So the stationing for your ditch center line is not the same as the stationing for your toe slope feature, which is not the same as the stationing for your roadway. It's 3 different things, and it's easy to get them confused. The point that I want to really emphasize here is that when we created this ditch corridor model, we selected our toe slope feature as the baseline. So as far as any edits that we want to make with this ditch corridor model, and when we have to specify stationing, it's the stationing of this toe slope feature that we need to use, because that is the control for the ditch. All right, it's not the stationing for the ditch center line. When we specify parametric constraints, when we specify point controls, all those stations are in reference to the toe of fill slope. Okay. And then later, once this is established, we can come back and use a tool that will give us the roadway baseline and offset for different PI points along here. So I just wanted to make that clear, because that's a point of confusion that often trips people up. All right, so I've now created a profile. I would like my ditch to follow this profile, not this crazy profile here. And so I'm going to use this information to create point controls. Now I've just said that I can't use the station base. Notice that this profile is the center line. This is a profile along the ditch center line. Excuse me. And so this starts at station 0. But the profile, the ditch corridor actually starts at station 333 based on the stationing of the toe slope lines. So I need to convert. I need to know what the stations of these PI points are according to the stationing of the fill slope line, not the stationing here. So the tool that I'm going to use is the Analyze Point tool. And that will allow me to convert the stationing. So the prompt here is select element to analyze point. It's asking me for the baseline. What baseline do I want to use to analyze point? Excuse me a minute. I need to cough. Apologize. I just need to clear my throat for a minute. So we're going to identify this toe slope feature as the baseline for analyze point. Well, once I've done that, you can see it's tracking along that line now. I could come in here now to my profile. Do that again. And now I can snap to my different PI points and get the correct stationing. You can see the readout there gives you a station, gives you an elevation. What you need to do then is to go through each of these PI points and then write down in a tabular form, write down the station and elevation of each of your PI points, and then do the math to figure out the slope for each reach. For the point controls, you will need the starting station and ending station, the starting elevation, and the slope, the grade. We're going to use the method called elevation and grade, so you can extract that information using the Analyze Point tool. You can get the new station for each one of those points. All right, so I've gone ahead and done that. Now I'm going to use that information to create a point control. Once you've extracted that information from your profile, you don't need that profile anymore. You can go ahead and delete it. Come back here. Corridor creation tools. And now I'm going to use a tool called point control, create point control. You need to specify the stationing for the first reach of my profile. It's going to start at 333 and go to 415. That's the first reach. I'm going to give my point control a name. I'm just going to call it ditch invert. Then I need to identify the point. These are all the points in the template. And the point that I want to control is a point called ditch bottom right. If you're not sure which one, go over to your template and identify, the name of the point. And that's the point that we want to change. We want to specify the elevation of that. So that's ditch bottom right. Mode, 3 choices here, horizontal, vertical, or both. When I override this point, I can force it to follow not only vertically, but horizontally. If I have some linear geometry to follow, but I just want to change its vertical location. I don't want to change the slope. I'm going to maintain that force slope and let that float horizontally. So I'm going to use the vertical mode. I've got a number of different ways of applying point controls. I'm going to show you this linear geometry method next. Right now, we're going to use elevation and grade. So my first elevation It starts at 524. And the slope of that first reach is 1.07%. And now I need the data point to accept all those inputs. As I walk through this, watch how this profile changes. As I add the point controls reach by reach, you'll see this profile change. So I'll do my next reach. Identify the point that I'm overriding, that I'm controlling. Keep vertical, elevation in gray, looks good. Change my starting elevation for that reach. And the slope. And data point to accept the inputs. Next one. See, this is 526.58. Accept the inputs. Next one. Just this one and one more to go. And then one more. All right, there it is. So I've now revised the profile of the ditch corridor using point controls. Now we've eliminated all those high points and low points. Go ahead and turn off display of my 3D model reference. Let's see, that's already off. Oh, I think I want to turn that on. There we go. Go ahead and turn that on. It's the 2D view that I want to change. And in the 3D view, turn off everything but the contours. And now I've got a grading plan. So there are my proposed contours from my ditch. Now it looks like it should. No high points and low points all the way down to the end. I'm going to go back here and turn on the layer, the level that has my graphics, my open roads graphics, so I can work with my design, these handles. And I want to show you this one tool under corridor creation tools. It's called the corridor objects tool, or as we like to call it, the bucket list. If you open this up, this is a one-stop shopping. It shows you everything that's in your corridor model. The template drop that you used, which you can then go in here and change if you want. Parametric constraints, if you've used any to change dimensions. Here are the point controls that I just put in. All right. If I want to, I can use this tool. To change that slope, that very last slope, I can come in here and I can monkey with this if I want. I can change that slope 2%. All right, you see that the profile updated and the grading updated as well. I can look at my 3D model view. All right, so that's method one for how to apply a point control to come up with your independent ditch profile. I want to show you a second way of doing this. I prefer the second method. Go ahead and close this file. And the second file is the same project. Just going to pick it up where we left off before we applied the point control, so I can show you a different method of using point control. Okay. So this is where we left off when we had just created the ditch corridor model, and we have the default template that we specified following the profile. So now we want to use a point control to enter in a good profile. So I'm going to use the information that I had from last time. I'm going to turn off my persist snaps just like before. I'm going to go ahead and to clean this up, this view a little bit. Help me out. I'm going to turn off display of the 3D model. And what I'm going to do is I'm going to create a horizontal alignment along my ditch center line. I'm going to create a horizontal alignment, and then I'm going to give it the profile that I want. And then I'm going to use that linear geometry as my point control rather than profile and grade. So I'm in geometry tab under horizontal tools. First, let me set my default feature definition. All right. And complex by PI. Make sure my radius is set to 0. And I'll start at the downstream end and work my way up. Now at this point, laying out this horizontal alignment, I'm going to roughly lay it along the ditch center line, but I don't really need to take care too much exactly where it is. It doesn't matter, because when I apply the point control, this ditch is going to shift anyway. So I'm just going to roughly lay this in. It is important, however, that you make sure that you have your persist snaps and rule turned off. The reason why that's important is that I'm going to use this linear geometry to make a modification to my ditch corridor model. And it is a rule in open roads that you cannot use a feature of a corridor model to make modifications to that same corridor model. That creates a circular dependency, or what open roads calls a recursive solution. If you try to do that, you will get an error that will say recursive solution. All right, so I have my AccuSnap on here, so you can see I'm snapping to this thing, but I don't want to create a rule, all right? Because that will then leave this horizontal alignment dependent on the corridor model, and I won't be able to use it for control. So I need to turn that toggle off so that no rules will be created, no dependency will be created between this line that I'm creating, this geometry, and the corridor model. So I'm just going to lay this in pretty rough. Along the ditch center line. It's not terribly important, really, how accurately you lay this out. And I'm not seeing it because that level is off. There we go. So there's the horizontal alignment that I just created. Now I want to create a profile model for that horizontal alignment. I've got a horizontal alignment. I need to give it a profile. I'm going to select it, go to open profile model. I'm going to put that in window number 5. All right, so what do I have here? I've just cut a profile along this horizontal alignment that I created. And that's what Open Roads will give you. It will show you a cut through your active terrain. I would like to see other information in there. I would like to see what's going on with that ditch corridor model that I created. And the way to do that, your cross-section view shows you automatically, dynamically shows you everything that's in your 3D model. That's not the case with your profile. If you want to see, information from your 3D model in your profile, you need to create what's called a 3D cut. So there's the tool right there, create 3D cut. I'm going to select the method using corners, specify the upper left, lower right corner. And now it cuts through the 3D model, and I can see here's my profile for the ditch that I have. And it's actually also cutting through a utility that's out there. Unlike the cross-section viewer, right, this is not dynamic. This is a cached graphic. It's a static. It just slices through the 3D model at that moment in time. So if your 3D model changes, you'll then need to go and use this tool, refresh 3D cut, to refresh that view. And so I'm going to go ahead now and lay out some geometry for this horizontal alignment. Okay, this is the profile of my horizontal alignment called Drainage Align 1. We'll use that same tool that I used before. Profile complex by PI. Got my persist snaps turned off. My vertical curve parameters are 0. Okay, go ahead and lay that in. I could now use Civil AccuDraw to lay my PI points out by station elevation if I want. I'm not going to do that. I'm just going to go ahead and freeform this in right now. Save a little time. And then end it there. Reset, exit. So there's my profile that I would like my ditch to take. I'm going to select that. And don't forget this step. Set that profile as active profile. If you don't do that, you won't be able to use the profile for your profile controls. All right, so that's done. Now I can apply a profile, a point control to my ditch corridor. I've got a horizontal alignment, I've got a vertical alignment, and now I'm going to use that. Grab one of my corridor handles here, corridor creation tools, back down to create point control. And so this is the same as before, except now I'm not going to specify point control for every reach. I'm simply going to call out this linear feature that I've created. And so the start and end, I can put in the stations of the entire ditch corridor, right from the beginning to the end. The point that I'm going to control is the same point as before, ditch bottom right. Still use vertical mode, but now I'm going to change my control type. Instead of using elevation and grade, I'm going to specify linear geometry. It sees that I'm asking for linear geometry. So now I have to identify, well, which linear geometry do I want to use? You see these are all the available linear geometry that exists in the file. So I'm gonna go ahead and select the one that I created. That's this one right over here. And when I select that, it finds that that does indeed have a profile associated with it. See here it says active profile. Had I not gone in here and said set that as active profile, it wouldn't be here and then I wouldn't be able to use it. All right, I've got everything I need in here. Now I just need to go ahead and data point to accept all my inputs. All right. Now you can see, remember I said before, we didn't see any changes in the profile because this is a static graphic. It's not dynamic. So I need to go up here and refresh this. All right, you see that did change quite a bit, but I still have, why is it that my ditch profile doesn't apparently follow the profile that I created? And the reason is that I was just guessing when I laid out this horizontal alignment. Once I change the profile, remember you change the elevation of your ditch bottom, it moves horizontally, right? Because we want to maintain that force slope. And so this ditch location has shifted quite a bit. And what I'm seeing here is I'm seeing a cut along this line, the horizontal alignment that I created. And it no longer follows the ditch location because the ditch location has moved. However, I'm going to go ahead and just slide this window out of the way so we can compare. This is the profile of the actual ditch center line. Wherever it goes, this profile belongs to the ditch corridor centerline feature. And so you can see it is doing what we want it to do now. If this bothers you, that they're not on the same place, then what you can do is you can come in here and just make some adjustments to the horizontal location of the geometry that you created for control. You can grab that point, you move it down here. And do that all along the alignment. And again, this doesn't have to be perfect. You're just making this a little closer than it was in the first shot. And this isn't even strictly necessary. I mean, you saw how that profile came out just fine. But I'll go in here and I'll make these changes. Just so you can see that they'll match. Now that's pretty close. It's reasonably close. The geometry is following the new location of the ditch. Not exact, doesn't have to be. So I'll come over here, view window 5 again, refresh my 3D cut. Now you can see it's pretty close. Okay. Notice that I have a problem at the end here. And that's because with the changes I've made, the length of the profile here no longer ends at the length, because the ditch is changed. I need to come in here and just resnap my endpoint to the end of the ditch. There we go. Here we go. And now that fixes that little problem. And do a last refresh. If you want to make changes to your ditch profile, this is your control. So you can go ahead and make changes here. For example, want to change this elevation, and you'll see that reflected in the actual ditch profile itself. Okay. So you can go ahead and this is I think an easier way of controlling your ditch profile by laying out some geometry like that rather than using elevation and grade. So those are two different ways. And I think we're about out of time. So Chuck, I think we can go ahead and answer any questions that people might have.
Okay. Thanks, Carl. That was great. If anybody has any questions, you just put them in the Q&A while we're closing this out now. Just to let you know, this video will be on our YouTube page probably by the end of the day, if not by tomorrow afternoon. Most of you know where that is. If you don't, just go to YouTube and search Great Lakes Bentley User Group. Plus, I'll send an email out to the group saying it's uploaded. Again, grab your information. We'll get you PDH credits. That'll be in your Bentley, learn.bentley.com area. Hopefully you know where all that is. If not, just shoot me an email. I do not see any other questions, and looks like I said, Zen Engineering will be giving us 5 more webinars throughout this year. We hold them every other month, so the next one will probably be March. So if nobody has any other questions or any questions, I want to thank Zen Engineering and Carl for doing this. And looks like we're all set, no questions. So thanks again, Mark and Carl, and we look forward to hearing from you guys in a couple months.
All right.
All right. Thanks, everybody.
You're welcome.